Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to solve certain numericals on Heisenberg Uncertainty Principle. In the previous video, we have read about the Heisenberg Uncertainty Principle. So today we are going to do its numericals. So first of all, I'm writing down the formula which I'm going to use while solving the numericals. So first of all, the change in position is mentioned by delta x into the change in momentum or uncertainty in the momentum is delta p, which is greater than or equal to the h upon 4 pi, where h is the Planck's constant whose value is, we know that, 6.626 into 10 to the power minus 34 joules second. This is the value of h. Now we can also write it as the uncertainty in the position will be equal to the mass into delta v, the uncertainty in the velocity, because momentum is mv, so delta p will be equal to m delta v, because mass of any subatomic particle remains constant. So there will be the change in the velocity which will change the momentum of the subatomic particle, which is greater or equal to the h upon 4 pi. So let's solve the numericals. Now let's see what the first numerical is asking. Prove that electron does not exist in the nucleus according to Heisenberg uncertainty principle. So for solving this numerical, let us firstly assume that electron is present in the nucleus. So I'm writing, let us assume that electron is present in the nucleus. After that, what's the diameter of nucleus? I'm writing diameter of nucleus will be 10 raised to the power minus 15 meters. So diameter of nucleus is 10 to the power minus 15 meters, and it is the maximum uncertainty in the position of electron. It is a maximum uncertainty in the position of electrons. Let's take it to be the delta x. Now, what is the uncertainty in the momentum? Delta p. It is m delta v. So now let's put the formula. Delta x into delta p will be greater or equal to the h upon 4 pi. Now delta x into m delta v will be greater or equal to the h upon 4 pi. Now let's evaluate the uncertainty in the velocity. So delta v will be greater or equal to the h upon 4 pi into m into delta x. So now let's substitute all the values over here. So delta v will be greater or equal to, what's the value of h? It's 6.626 into 10 raised to the power minus 34 divided by 4. What's the value of pi? It's 3.14. What's the value of mass of electron? It's 9.1 into 10 to the power minus 31 kilogram. And what's the uncertainty in the position? Delta x, it is 10 to the power minus 15. So uncertainty in velocity is greater or equal to 5.77 into 10 raised to the power 10 meters per second. So here you can see that uncertainty in the velocity exceeds the velocity of light, which is not possible. Hence electron will not exist in the nucleus. So here I am writing, since the uncertainty in the velocity exceeds the velocity of light, which is not possible. Which is not possible because in universe the highest speed is of light. So the change in velocity, the uncertainty in the velocity exceeds the velocity of light, which is not possible if electron will exist in the nucleus. So this proves that electron will not exist in the nucleus. So it proves that electron will not exist in the nucleus. Electron will not exist in the nucleus. So that was the first numerical. Please do have a look. Now let's move to the second numerical. In the second numerical, the question is asking if the uncertainty in the position is equal to the uncertainty in the momentum, calculate the uncertainty in the velocity of electron. So firstly here what is given? Given is uncertainty in position is equal to the uncertainty in the momentum, mark it as number 1. Now we have to evaluate the uncertainty in the velocity. Now let's use the formula. Delta x into delta p will be greater equal to the h upon 4 pi. Now let's substitute the value of delta x by delta p from the number 1. Now delta p into delta p will be greater equal to h upon 4 pi. So it's delta p square greater equal to the h upon 4 pi. Delta p comes out to be the root of h upon 4 pi. Now m delta v comes out to be the h upon 4 pi whole root. Now delta v comes out to be 1 by m into h upon 4 pi whole root. Now delta v comes out to be, let's substitute the values. 1 by m is 9.1 into 10 to the power minus 31 kgs into, what's the value of h? 6.626 into 10 raised to power minus 34 divided by 4. What's the value of pi? It's 3.14 whole root. So this value, the change in velocity, the uncertainty in the velocity, comes out to be 7.9 into 10 raised to the power 12 meters per second. So that's the uncertainty in the velocity. But again, the uncertainty in the velocity exceeds the velocity of light, which proves that uncertainty in the position and the uncertainty in the momentum will never be equal. So here I am writing the uncertainty in velocity again exceeds the speed of light, which proves that uncertainty in position and uncertainty in the velocity, momentum, and uncertainty in momentum will never be equal. So that was the second numerical. I hope you got this thing. So now let's move to the third numerical. In the third numerical, the question is saying electron has a speed of 38 meters per second and accurate up to 98.99%. what is the uncertainty in its location. So here in question, delta V is given to be 38 meters per second. So its accuracy, its accuracy is 98.99%. So then its uncertainty will be equal to, its uncertainty, or you can say its error, will be equal to the 100 minus 98.99, and this thing comes out to be 1.01%. 1.01%. So this is the uncertainty or the error in measuring the velocity of the electron. So here what we have to find, the uncertainty in the location, that is delta x. So first of all, let us evaluate the delta v. First of all, sorry, it is a velocity, it is just a velocity, that is 38 meter per second. We have to evaluate the delta v. Now we know that the uncertainty in the velocity is 1.01% of 38. So it comes out to be 1.01 divided by 100 into 38, and it comes out to be 0.3838. 0.3838, that is the uncertainty in the velocity. Initial velocity was given to be 38 meter per second. The uncertainty I have calculated to be 1.01%. So uncertainty in the velocity will be 1.01% of 38, which comes out to be 0.3838. Now we know that delta x into delta p is greater or equal to the h upon 4 pi. So delta x into m delta v will be greater or equal to the h upon 4 pi. So delta x comes out to be h upon 4 pi m delta v. So now let's substitute all the values. Delta x will be equal to the 6.626 into 10 to the power minus 34, that's Planck's constant, divided by 4. The value of pi is 3.14. The mass of electron is 9.1 into 10 raised to power minus 31, and the uncertainty in the velocity has been calculated to 0.3838. So the delta x comes out to be 1.5 into 10 raised to power minus 4 meters. So that's the uncertainty in the position of electron according to this given data. So now let's calculate the fourth question. Now in question number 4, a proton is accelerated to a velocity of 3 into 10 to the power 7 meter per second. So first of all, the velocity of proton is given to be 3 into 10 raised to the power 7 meters per second. Now very importantly, let me tell you that mass of proton is now 1.66 into 10 raised to the power minus 27 kilograms. In all the previous questions, the subatomic particle was electron. In this question, the subatomic particle is proton. Now question what next is saying, now if the velocity is measured with the error of 0.45%, that means uncertainty or error of velocity is given to be 0.45%. So delta v comes out to be 0.45% of 3 into 10 raised to the power 7. It comes out to be 0.45 divided by 100 into 3 into 10 raised to the power 7, and the value of delta v comes out to be 0.0135 into 10 raised to power 7 meters per second. Now, uh, calculate the uncertainty in the position of proton. We have to evaluate the delta x over here. Now, delta x into delta p greater or equal to the h upon 4 pi. Now, delta x, the delta p is m into delta v greater or equal to h upon 4 pi. Now delta x comes out to be h upon 4 pi m into delta v. Now delta x comes out to be, what is the value of h? Is 6.626 into 10 raised to power minus 34 divided by 4. What's the value of pi? It's 3.14. What's the value of mass of proton? 1.66 into 10 raised to power minus 27. Please always keep in mind which subatomic particle is given to you in the question, whether it's the electron or proton. In this question it was a proton, so its mass is 1.66 into 10 raised to power minus 27 kilograms into the delta v we have evaluated to be 0.0135 into 10 raised to power 7. So after evaluating the whole thing, the delta x comes out to be 25.34 into 10 raised to power minus 14 meters. So that's all for today. I hope you got the last numerical also. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then he can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.